Question 5 is coming from functions, particularly from a transformation of functions. In the diagram, the graph with equation y is equal to f of x is shown with solid lines, and the graph with equation y is equal to g of x is shown with broken lines. Part A, describe fully a sequence of 3 transformations which transforms the graph of y is equal to f of x to the graph of y is equal to g of x. Now, on the look of things, you can see that this part here corresponds to this one, and this one was enlarged. It was actually stretched. You see that? Then, of course, this one with this one here, and then this one with this one. But now, since this one corresponds to this, then it looks like it looks like they reflected it somewhere. Okay, they reflected it in a vertical line here. Now, usually, in most cases, when it comes to reflection, we have the reflections in the mirror lines. We have this y-axis and then the x-axis. So I think the first one here has to be a reflection in y-axis. So let me draw this one here, and then of course this one now will be here. Remember, for reflection, the image and the object must be equidistant from the mirror line. Okay, now this one is a diagonal in 2. That means I will draw a diagonal in 2. Okay, so I'll continue, and then I draw this one here. I can actually make this one dotted such that it doesn't interfere with what we are having, what we are given. So it is dotted there. Then the next one, we can now transform this one. There are 3. They said 3. That is the first one. Now we can see that based on how this one is, this one must have been shifted to the left. So suppose I shift this one. By the way, let me take this one as my first one here, reflection in y-axis. And then I'm going to move it like 1 unit such that it can be on this same line. This point here can be on this same line here as this one here. Okay. Also this one, when I extend it here, it will be, the point will be on this same line as this one here. So by doing so, then I can be in position now to stretch. So it's just to make this one bigger. Okay. Now I'm going to, let me actually use another color. I'm going to shift this one to the left by 1 unit. Okay. So when I do that, then this one will be here like that. And then we have this one here. And then this one will go up to here. So I've shifted it 1 unit. Again, I'm going to make it dotted such that it is far different from what we were given. So that is that. That is a translation because I just shifted. Okay. This is now the second one here. Then the third one is this one here. Okay. So now the third one, of course, when you look at the point here, you can see that the coordinates are -1, 3, -1, 3, but the coordinates here are -1 and then 6. So what was done to this 3 to this? That is times 3. Let us look at another one here. This one here is -5 and then 2. But then this one here, this point here is -5. The x is not changing, but the y is the one that is changing by multiplication. This one is 4. Do you also see that from 2 to 4, they multiplied by 2? So that is a stretch in the y direction. So first, let me write something small here. First, reflect f of x in y-axis. So that is my first one. Then shift the resultant function. Okay, shift the result to the left, to the left by 1 unit. All right. And finally, you stretch it. Then stretch by factor 2, right? Because we have seen the y coordinates are changing by, oh, I made an error here. Forgive me here. This one must be a times 2. 3 times 2, that is the one that gives us 6. Then stretch by factor 2 in the y direction. In y direction. So now using the language of transformation, now the first one we shall say it's a reflection in y-axis. Then next we have translation, because shifting from one place to another is a translation. We shifted to the left, okay? So by the vector -1, 0, okay? Then the multiplication that is to do with the stretch. So stretch by factor 2 parallel to y-axis. So these are the 3 that we are supposed to have here. This one, and this one. Then part B, find an expression for g of x in the form, this one here. Of course, now for reflection in y-axis, okay, for reflection in y-axis, if I have a point that I'm reflecting in y-axis, if I have a point here and I reflect it in y-axis, the x-coordinate is going to change. Here it is positive, this way it will be negative, but the y-coordinate remains the same because it is on the same line here. You see that? So the x-coordinate changes the sign. And if it changes the sign, that means we shall have y, which is equal to f of now negative x. Okay? Then translation by vector -1, 0. Here we are shifting to the left, but when you are popping this one out and you are putting it in the function, it changes the sign. So we shall have y is equal to f. Now, first of all, this x is a negative, it is there, but now we are doing a change on the x. So we shall have x then plus 1. When this one goes where x is, it will change the sign, okay? I've always shown this one here. For example, if we have this graph here, let's say y is equal to, let me use the simplest one, x squared. That is the graph there, okay? It's a U-shaped curve. And then I have y is equal to, then I say x, let's say minus maybe 2, and then squared. Okay, now you have seen that it has shifted 2 units to the right, but here I put a negative. Okay, so if I put a negative in here, and then here it has shifted to the right, that means the translation vector here is, by looking at this, the translation vector is 2, 0. That means this one, when it goes where x is in the function, it changes the sign. You see that? Okay, now that is why when I'm writing here, the -1, now it comes where x is, I change its sign, it becomes a positive. If this one were positive, then this one would have been a minus in here. But you have to be very careful because you are doing this transformation here on this x, which is already a negative. So that's why I'm putting brackets here and then I'm leaving the negative here because this transformation was already done before this one. Otherwise, if you come and then you write f of -x, then you say +1, you're already gone. This is a different graph you're going to get. Okay, so that is that. And then stretch. So the last one is stretch by factor 2, okay, in y direction or parallel to y-axis. This one is now going to be, of course, for the stretch, we use multiplication and division. So this one is going to be 2, then times what we are getting here, okay? 2f into this minus of x then plus 1. So that is what we are going to have. So meaning g of x is therefore going to be 2f. I can open the brackets here, and then I have minus x minus 1, like that.